better grade you can get. On exam 3, okay? All right, so section 3.4, right, we're continuing to factor polynomial functions. But in this case, right, 3.4, we're using the rational zeros test, okay? To find rational zeros of polynomial functions. And so we did the first example at the bottom of page 1 on Wednesday. So if you flip over your document to your handout, we'll take a look at the next example. And we have p of x is equal to 4x cubed minus x squared plus x plus 3. Now, how many zeros of this polynomial function are there? 3, right? Third degree polynomial, right? 3 zeros. If complex zeros come in pairs and irrational zeros come in pairs, how many rational zeros do there have to be in this polynomial function? At least one, right? If complex numbers come in pairs, that's 2. And irrational numbers come in pairs, that's 2. And we have a third degree polynomial, then we're sure there has to be at least one rational zero to this polynomial function. Okay? So we're not really wasting our time trying to find it, okay? Because we're guaranteed there's going to be one there. Okay? So 3 is the constant term. And 4 is the leading coefficient. Right? So to get our list of possible rational zeros, right, we need the integer factors of the constant term and the integer factors of the leading coefficient. Right? So the integer factors of 3 well, 1 times 3 is 3, and minus 1 times minus 3 is 3. Okay. And in shorthand notation, we can write this as plus and minus 1 and plus and minus 3. Okay. Eventually, we'll just be doing shorthand notation. Because if there are 30 right, possibilities, I don't want to write out all 30 of them. Okay. And then the integer factors of the leading coefficient 4. Well, 1 times 4 is 4. Minus 1 times minus 4 is 4. And 2 times 2 is 4. And minus 2 times minus 2 is 4, right? And shorthand notation, we write that as plus and minus 1, plus and minus 2, plus and minus 4. Okay. Now, to get the possible rational zeros, we we have to divide all the integer factors of the constant term 3 by each of the integer factors of the leading coefficient 4. So I just do it one at a time. So we're going to divide plus and minus 1 and plus and minus 3 up here by plus and minus 1. We have plus and minus 1 over plus and minus 1. And then we have plus and minus 3 divided by plus and minus 1. Okay. So I divided the integer factors of 3 by this first pair of integer factors, the leading coefficient, plus and minus 1. And now I got to divide plus and minus 1 and plus and minus 3 by plus and minus 2. Okay. You can see we're going to have a number, a possible rational zeros list is going to have several numbers in it. And then lastly, I got to divide plus and minus 1 and plus and minus 3 by plus and minus 4. So just carry along in these divisions, simplifying these fractions, just carry along the plus and minus. You know, 1 divided by 1 is 1. 3 divided by 1 is 3. So the first two quotients simplify to plus and minus 1. The second one simplifies to plus and minus 3. The third quotient simplifies to plus and minus 1/2. The fourth one simplifies to plus and minus 3/2. The fifth one simplifies to plus or minus 1/4. And then the last one simplifies to plus and minus 3/4. How many numbers are in our possible rational zeros list? 2, 4, 6, 8, 10, 12, right? Plus and minus, this means plus 1 and minus 1 are in our list. Plus 3 and minus 3 are in our list. Plus 1/2 and minus 1/2 are in our list. So there are 12 possible rational zeros. Is that enough? Or do we want more? It's enough for me. Okay. And so what's the next step? So we know there's at least one rational zero to our polynomial function p of x. So what's the strategy for finding the first one? Trial and error, right? That's what it says on page 1, right? Once you get the list, it's now trial and error. Okay. So 1 and minus 1 are usually easy to work with. Okay. So I evaluated p of x at x equals 1, and I got 7 for the value of p of. So x equals 1 is not a 0 of our polynomial function. Okay. Then I evaluated p of x at x equals minus 1, and I got minus 3. Now, there is some good news here. polynomial functions are continuous, this means that the 0.17 is on the graph of the polynomial function, and this means that the point -1, -3 is on the graph of this polynomial function. So here's the 0.17, and here's the point -1, -3. So here's -1 on the x-axis, here's +1 on the x-axis, and somewhere between -1 and +1, the graph of the polynomial function has to cross the x-axis. And where it crosses the x-axis, that is a 0 of the polynomial function. So we can, deductive reasoning, we can conclude there must be a 0 between -1 and 1. Okay? Unfortunately, looking at our list, those are fractions, right? That's plus and minus 1/2, plus and minus 3. That won't include this one. This is too big, but it could be either plus 1/2 or minus 1/2, plus 1/4 or minus 1/4, or plus 3/4 or minus 3/4. Okay. One of those 6 numbers works, and the only way you can find it is trial and error. Pick one, plug it in for x, and see if you get 0 for the value of the polynomial function. Okay. So, and when I did this, right, I did it just like you. I just started grabbing numbers and plugging them in. So I tried x equals 1/4. So p of 1/4, when I plugged in for x on the right hand side up here, I got 13/4. Well, that means the point 1/4, 13/4 is on the graph, which is 1/4 is just to the right of the origin, okay? And so this point's above the x-axis, this one's below. So somewhere this polynomial has to cross the x-axis between -1 and 1/4. Okay. So that means I can sort of zero in on -1/2 and -3/4. Okay. I guess I could zero in on -1/4 as well. Okay. On the negatives, okay, of these 3 fractions. And so I tried -1/4. And when I put in -1/4 in for x on the right hand side, the value of the polynomial was 21/8. That's a positive number, right? So here's like -1/4, 21/8. It's like up here. So again, the graph of the polynomial, right, has to cross the x-axis somewhere between x equals -1 and x equals -1/4. Okay. And so I tried x equals -3/4. And when I put -3/4 in for x, bingo. The value of the polynomial function is 0. P of -3/4 is equal to 0. And so x equals -3/4 is a 0 of p of x, right? Which means x plus 3/4 is a factor of p of x. Okay. So we found one of the 3 factors. one of the three zeros. So we got two more to go. Okay. Can I erase this to the left? So what remains isn't really that bad because it's what we've already been doing. So P of X, the right-hand side, has X plus 3/4 as a factor. And since this is a third degree polynomial, X plus 3/4 must be multiplied by quadratic, right? Quadratic times a linear factor equals X cubed, okay? So this inside parentheses, right, is a quadratic of the form ax squared plus bx plus c, okay? So when you multiply first terms, okay, even we probably know a is going to be equal to 4, because we'll have 4x squared times x is 4x cubed, okay? But I haven't been writing out the quadratic like that. I've been writing it out as times q of x, some quadratic. Well, q of x is equal to p of x divided by x plus 3/4, right? Can we do that division? The short answer is yes. Do we need to do long division? Can we do synthetic? Absolutely. Okay. So let's do the synthetic division. Okay. So what goes in the box? What number goes in the box? Yeah, remember it's not plus 3/4, it's minus 3/4. Okay. X minus c is equal to x plus 3/4, which means c is equal to minus 3/4. And then you write out the coefficients of the polynomial descending powers of x, right? 4, minus 1, 1, 3. Now you're working with fractions, so you've got to be on top of your game with the fractions, right? So you bring the 4 down. Minus 3/4 times 4 is minus 3. Minus 1 minus 3 is minus 4. Minus 3/4 times minus 4 is plus 3. And 1 plus 3 is 4. And minus 3/4 times 4 is minus 3. Remainder 0, which we better get or we did something wrong. So our quotient from our synthetic division, right, this 4 goes with the 1, this one goes with x to the first, this one goes with x squared. And so our quotient from the synthetic division is 4x squared minus 4x plus 4. So our third degree polynomial divided by x plus 3/4 is equal to 4x squared minus 4x plus 4. So this on the right-hand side up here can be written as x plus 3/4 times 4x squared minus 4x plus 4. So to get the last two factors and the last two zeros, we set this quadratic equal to 0, right, and solve for x. Okay. Now, we should note that we can factor out a 4. That's actually the leading term up here. And we're left with x squared minus x plus 1 in parentheses. So it's x squared minus 1 plus 1 that we need to set equal to 0 and solve for x. So a is equal to 1, b is equal to negative 1, c is equal to 1. So using the quadratic formula, we'll get the two remaining zeros, right, of our third degree polynomial. So we have negative of negative 1 plus or minus the square root of minus 1 squared minus 4 times a, which is 1, times c, which is 1, all over 2 times 1, 2 times a. Well, when I do the arithmetic, I get 1 plus or minus the square root of minus 3 over 2. Which is equal to 1 plus or minus I root 3 over 2. So x equals 1/2 plus or minus the square root of 3 over 2i. To write it in standard form. Remember, the I is not in the numerator or denominator, so we can't end up under the square root. And so x equals 1/2 plus the square root of 2i, and x equals 1/2 minus the square root of 3 over 2i are the two remaining zeros. I guess I erased the first one, right? The first one was x equals minus 3/4. Okay. Any questions on that, ladies and gentlemen? Okay. And now you can do the complete factorization of p of x. Bring the 4 out front, multiply it by x plus 3/4, and then write out the factors of x squared minus x plus 1. Sure, x minus 1/2 minus the square root of 3 over 2i times x minus 1/2 plus the square root of 3 over 2i. That is the complete factorization of p of x. Any questions on that, ladies and gentlemen?
I have a question.
Yeah.
How do you know when you can or cannot do synthetic division?
It had when you I erased it, but when you divide the polynomial by a linear polynomial, where it's x to the first power. If it's x squared or x cubed, x fourth, you can't do it. It has to be x to the first power. right, you ready to take a quiz?